everybody, and welcome to Coastal Insights. And my name is Maureen. I'm your host for today, and I'm super excited to be presenting episode 8 in our live and interactive online learning series. And so this series has gone so far beyond my expectations. I've been learning so much each week with each new guest that comes on, and we have a new topic each week to help people understand their coastal environments and the Pacific coast of British Columbia. So I'm joining you live today from the Kwakwaka'wakw First Nations traditional territory here in the very northern tip of Vancouver Island. It's a beautiful place I now call home. So you can see some of my lovely background behind me. And I'm super excited that everyone's joining today. So we have been having lots of different guests from all over the world, really, and different topics each week. So today's topic, I'm super excited to be presenting with two of my colleagues. And so generally I have hosted in the past some of these episodes, but today I'm going to play two different hats. So I'm going to be hosting, but also presenting. And the topic for today is very interesting. So in the last several decades, it's been gaining more and more interest, more and more fascination, and more awareness on these animals. So we're talking today about killer whales, and specifically killer whales of the Pacific Northwest here in British Columbia and up the coast. And so we have today my special presenters, and I'm very, very happy to be presenting today with our different colleagues. So I have the triple M's coming at you today. So myself, Maureen, I'm the education coordinator for Raincoast, and I run a program called the Salish Sea Emerging Stewards Program. So it's a super inspiring, transformative program where we get to work with lots of great youth to help connect them to the environment and to some of these conservation issues. And so speaking of our program, I'm going to introduce you our other presenter, which is Miriam Holmes, and she is a grade 12 student who was part of our Salish Sea program. So she was a program alumni, but now has joined Raincoast as a junior leader and has been training with us for a full year to be learning more on some of these coastal issues. And so Miriam, if you want to say a quick hello to everyone.
Hi, everybody. I'm broadcasting from the traditional territory of the Penelakut, Halal, Jemanis, and Myaxin, and this is my virtual background of whales.
Yeah, she's getting super creative with her backgrounds, and Miriam has been helping out lots with our webinar series, and so she's quite familiar now with what we're doing here. And then we have the one and the only Misty MacDuffee, our wild salmon program director and Raincoast scientist. And she is one of our ambassadors and champions of a lot of these issues on the coast. So I'll pass it to Misty to say a quick hello.
Thank you both. It's an honor to be presenting with both of you. And I'm at my home on Pender Island, and Pender Island is in the traditional territory of the Wasanich.
Awesome. Perfect. So you will be hearing from everybody today. Throughout the program. We're gonna be tag teaming throughout this program, but this topic is such a great topic to delve into because the iconic killer whales of our coast here, they're very complex. There's lots to their language, their family dynamics, their diets, their differences between ecotypes, and so today we're going to be delving into understanding more about that and learning about some of the major threats that they're facing today. And so I'm gonna just get started here and share my screen with you. Here we go, share. So oops, hold on, stop share for a sec. I'm just gonna make sure I'm on the right thing here. Okay, let's try that again. Okay, so feel free to type in the chat box too if you can't hear anything, if there's any technical difficulties. We will do a Q&A session at the end of this episode. I'm sure there's going to be lots of great questions. But throughout the program, if you do have a question, just type it in the chat box or in the Q&A box that you see at the bottom of your screen. And then we will be able to interact with everyone after the program. So I'm going to start with this image here. And this is what a lot of people will think about when they think of killer whale, this big, gigantic, black and white image. And so I was very fortunate to be able to work in the Whale Museum here in Northern Vancouver Island. It's called the Whale Interpreter Museum. And it was an amazing place that allowed me to really see underneath these creatures and look at their skeleton. And so from their skeleton, you can actually learn a lot about their evolution and their history. And so this is what I would see in the museum. And if you look very closely at their pectoral fins, so these are their side flippers, it looks like that. This is what their bones look like on the inside. And so if you look closely at that, it kind of looks like a hand. And so that actually indicates a lot about where these animals have come from. So all of these killer whales, all these whales, were actually once land animals. So they once roamed the land, walked on earth, had legs, had hands. And so throughout time, they've actually moved into the ocean. They've changed shape, adapted to that environment, and streamlined a lot of their appendages. And so now you just see that flipper where there once were digits, similar to our hand. And then if you notice this tiny little bone here, so that right there is called the vestigial pelvis. And it's a remnant bone from when these animals had limbs and they were walking and they had legs. And so now it's just reduced to this tiny little bone. And oftentimes when people in the museums, whoever is articulating these animals, will put together this whole skeleton, find this little bone, not know what to do with it, and then throw it away. So oftentimes it might go missing, but if you do see a whale skeleton, they should have this tiny little bone associated with it. So that's a little interesting tidbit. And so this is a theory of what this animal might have evolved from. And so this is the evolution of what the killer whale could have looked like. And so it could started maybe as this coastal carnivore, this carnivore type of animal. And you can see it could look really different. It has different claws and hands. And then through time, millions of years, maybe it decided to go into the ocean. And so from that, the ocean environment is quite different. And today, we recognize this nice streamlined form that we see with the killer whale. But this event, the past in millions of years, is what it would have looked like. Okay. So Miriam's going to help me out here, and she's going to launch a poll for you. It's going to have just 2 simple questions. So Miriam, just let me know once you've watched the poll, okay? 2 simple questions, and this is where we get interactive. So I'm going to ask the attendees, okay? I want you to take your vote just of these 2 questions. 1, is a killer whale a killer? 2, is a killer whale a whale? Okay? So just put in your answers. I'm going to give you 5 seconds to put in your answers, and then we're just gonna tally up all those votes magically with technology, and then see what you guys got here. Okay, so it looks like everyone's done their poll. I'm gonna end the poll. Well, I don't know if I can share it. Okay, so from this poll results, I see number 1 question: is a killer whale a killer? Okay, 75%. I'll share the results. Oh, right. Awesome. Okay. So is the killer whale a killer? 75% said yes. 25% said no. It is, in fact, a killer. So yes, it is a killer. Is a killer whale a whale? 25% said yes. 75% said no. Okay. So I'm going to stop that poll. Good guesses. So killer whale, definitely a killer. It has to eat, right? So it's going to kill something. Is it a whale? No, it is not a whale. And so it's a dolphin. A lot of people have this misconception that a killer whale is a whale, and it's validated because it's right in their name, killer whale. So why would you call it killer whale if it's actually a dolphin? It's the largest species of dolphin. So this goes back to the times where people were out on the waters, goes back centuries, maybe thousands of years. It has a really bad reputation. So it's got a killer reputation. So if you were out in the water and you witnessed a kill from these killer whales, it would be quite graphic. It would be very memorable. Maybe it's fascinating, but definitely pretty gruesome. And so all over the world, whoever witnessed these attacks or killings, they gave this animal a killer name. So all over the world, we have different names for this animal. So for Norway, they call it spake hugger or blubber chopper. In Portugal, they call it baleia assassina or assassin whale. And Germany, they call it murder whale or murder whale. I'm sure I'm butchering all these languages, so I apologize to any Germans and Portuguese out there. And Aleut, they call it polo satik, or the feared one. And so there's this underlying theme with all these countries all over the world. People have named this animal a killer animal. And so some people are shifting that language and preferring to call this animal an orca because it doesn't sound as menacing. But the orca, so the name orca comes from the scientific name Orcinus orca. And so if you actually break down what those two words mean, Orcinus actually means of the kingdom of the dead. And orca means large bellied pot in reference to its shape. And so either way you spin it, it's associating this animal with a killer animal. So you can choose to call it orca, but still means belonging to the dead. All right, so I'm going to show you this beautiful image. And throughout the world, there's actually 10 different types of killer whales. A lot of people don't realize, they think that's this one animal all over. But throughout the world, they're found in all oceans, all over the world. And there's 10 different types. So I'm going to pass it to Miriam now to explain the types that we actually have on our coast, because we don't have all 10.
Thanks, Mel. Yeah, so if you look here, there's obviously more than 10, and that's because on the left side of each ecotype is,
Sorry.
One, Mel. On the left side of each ecotype is the male, and on the right is the female, just for some perspective. So yeah, as Mo said, there are 10 different ecotypes of killer whales in the world. And as you can see, they all they look fairly similar, don't they not? They look pretty identical. There's some differences in appearance in some of them, but we're gonna look at the killer whales in our area of the Pacific Ocean. And that is the resident killer whales, the bigs or transient, and the offshore. So we're gonna talk about how basically these, though they look so similar, they differ in many ways. So they are all genetically distant from each other, distinct. And so here, I'm just gonna ask you to go back one more. There you go. Okay. So you see, if you were to see all of these in the ocean, you probably wouldn't be able to tell them unless you had a very distinct eye, right? They all look fairly similar, but they all differ from their diet, their vocalization, meaning the language they speak, which we do call vocalization, and then their behavior, where they live and how they live, roam, and hunt. So we're going to talk about residents to start with. Residents have two distinct populations. There's the northern residents and the southern residents. So to the next slide, you can see here in this map, it shows out where they kind of roam, but the residents is also a misleading name because it doesn't mean they're permanent residents of this area. They're ever traveling and they're only here usually in the spring and summer for feeding grounds. So the northern residents are kind of in the area from mid-Vancouver Island up to up north, and then the southern residents are from mid-Vancouver Island and down south to around Washington. But mostly they're here during spring and summer to feed. So if you think, what would they be feeding on during these times? If you think salmon, you'd be correct. So resident killer whales, their diet consists of salmon, which over 80% of that is all Chinook. And if you know more about salmon, you can think of the size of Chinook. It's the biggest, so big whales need lots of nutrition. So you think that's where they get it from. So something you might not know is that salmon don't have very good hearing, which allows the residents to travel in bigger pods up to 20, say, and they can also be very vocal. So they can be in larger groups, highly vocal, communicating with each other, because they don't really need to sneak up on their prey. Comparatively, if we go down to bigs or the transients, they travel in smaller pods, groups only up to like 10 maybe, but preferably smaller, and they're less vocal while they're hunting. And if you can think of maybe reasons why, what would they be hunting that they have to be quieter? So probably something that has better hearing. And if you think mammals, you'd be correct. So bigs and transients eat only aquatic mammals like seals. Other things about bigs, they're basically, the reasons why they're so small in groups is because they need to be in the stealth, sneaky mode to hunt. So now that leads us to our offshore. Now our offshore, there's very little information that we have on offshore. Thinking of the name, it means that they're farther off in the ocean, and so there's less information that has been collected by scientists because of where they are. So we're going to go to the next slide here. Now this is a tooth diagram. Here you have the residents on the left, and they eat mostly fish. There's a bit wear on their tooth, but not much. You go to the transients, who eat mostly marine mammals. Obviously, the size difference is much bigger, so they have a bigger wear on their tooth. And then you go into offshore, and their tooth is completely worn down, and you think, what could they be eating that wears that tooth all the way down? And so you have to kind of think it's got to be something tough and big, and I'll let you figure that out, and then I'm going to tell you they're shark eaters. Now this was actually a really big surprise to me. I was amazed, but the reason why their teeth wear down is because of the shark's skin. So this is a microscopic image, and it's basically like sandpaper. See all of those really sharp scales, it's just wearing down their teeth. So if you ever find a tooth on the beach or something and it's worn down and you think it might be a whale, it's most likely an offshore. It's a pretty good indicator that it is. So now I'm gonna switch back to Mo, and she's gonna talk about Dr. Michael Biggs.
All right, so that is the name that you are hearing to describe what was called the transients, but now they're shifting the language a bit to Biggs in memorial and to dedicate to Dr. Michael Biggs, who was the forefather, pioneer researcher who basically discovered all these differences between the ecotypes. So in the 60s, he began studying killer whales and would take photographs of each killer whale that he would encounter out in the water. And so they would always take a photograph of the left side of the killer whale to be consistent, and it would always include that dorsal fin along with this white patch behind the dorsal fin called the saddle patch. And so together, those two make a fingerprint. So every dorsal fin has different shape to it, different nicks, different cuts, as well with the saddle patch. It has different patterns, different scratches, and different shapes. And so by studying this really closely, you can really identify different individuals and see what type of behavior they're displaying. And so from this, he realized, oh, all these killer whales are behaving very differently. They're not eating the same things. They're not behaving the same way. I don't know what's happening here. Miriam? Okay, there you go. And so, yeah, so he was the one who discovered that we have 3 different ecotypes. And so I'm just going to show here, this is courtesy of the Whale Interpreter Museum. So that museum I was talking about up in the North Vancouver Island area. And this is a mural that really displays the family dynamics and grouping. So I'm using this as an example, but we're going to shift into talking about the southern residents after this. And so each family is called a matriline, and that's a single individual close-knit family. And so it's led by a female leader. Who runs the world?
Girls.
That's right. And so in the killer whale world, that is absolutely the case. The females are the all-encompassing knowledge holders. They're the ones that lead their family through the waters, teach them how to hunt, show them where to go in harsh times, and they're the ones who pass down the language. And so one individual family is called a matriline, led by a female leader. And so that's zoomed in of one family, let's say. All those gray boxes are death, but the dates represent their general age, birth age, and then you can see they're female or male. But the males will have the taller dorsal fin. Females generally have a smaller curved dorsal fin, so that's how you can tell the difference. And this female has 5 calves. 1 died, and so 4 remaining. And this family will stay together for life. So this is specific to the residents. The other ecotypes, so the transients, offshore, they don't show the same family groupings as the residents. So some of the members might go off and never come back, whereas the residents, they stick to their family very closely. So if you see one individual and recognize that, you know that everybody else is close around. And so let's keep going. So one family is a matriline, and a female might eventually, the daughters, let's say, might eventually branch off and make their own family, and that's called a pod. So when 2 different matrilines travel together, 2 or 3, that's a bigger group, and that's called a pod. So it could be just a family, big family traveling together, but the sons will stay together for life with their moms. And so let me give you an analogy. So for all the moms out there, it would be equivalent to having your adult son live with you, maybe in the basement, playing video games, who knows. But they will live with you for life, and you will support them and hand feed them, because these females and the leaders, they will catch fish and share it with their families and share it with the sons. And so it would be analogous to you feeding your son for life. And so that's true dedication. But yeah, so that's how they work in the killer whale world. So that's a pod. And so now if you look at the color coding, this is now dividing them by dialect or by vocalization. So almost like language. And so we call that a clan when they all have similar dialects. And so there's the A clan, the R clan, and the G clan that represent the northern resident community. There's one more clan that I couldn't fit in. But all these clans are very distinct. And so these killer whales, they know the differences as well between different clans, so they can recognize that. So generally, they will not mate within their clan. Anybody want to guess why? So feel free to guess why. Why would you not want to mate with somebody that has a similar dialect or vocalization? And so somewhere along the line would be a common ancestor that passes down this language, because all the language is passed down from the mom. And so if there is similar dialect, somewhere along the line might be a common ancestor. So to avoid inbreeding and to spread your genetic diversity, it's safest to mate outside of your clan. So often pod. And so oftentimes they will mate outside of that. And so I'm going to play with you. I'm going to play for you some of the sounds, and I want you to see if you can hear some of the differences between their dialect and between their vocalization. So I'll play this one right here first. Let's see. a good sense of what they're saying. I don't know. We don't know what they're saying, but we can always try to guess. And so that's their dialect. And so hopefully you can hear some subtle differences, or if you notice some obvious differences. There's one more clan. I'm going to play their vocalization right here. So those are the three clans we find in the northern populations. And I'm just going to play here. So in the southern population, so the southern resident killer whales, the ones we find in the Salish Sea, we call that the J clan. They have one clan, and it sounds like this. Oops. Okay, I'm gonna go back. So the residents have a certain sound. The transients, oh, I don't know why. Okay, I'm not sure why my, oh, there we go.
There
Okay,
it is.
so transients, they sound like this. So it sounds quite different from the residents. So we mentioned earlier they have very different prey and different food sources. So you could actually have a dolphin swim right alongside a resident and even like play or taunt them. But as soon as they hear a transient, they will bolt. And so even the prey know the difference between their vocalization. And so I'm going to play this last one. These are the offshore, the shark-eating ecotype. All right, so that's just a little sample of some of the killer whale calls and their sounds. And so now we're talking today about the southern resident killer whales. So these are the ones in the Salish Sea. And there's a lot of discussion and concern around them because they are critically endangered. So I want you to guess, you can put it in the chat box, how many southern residents are actually left. I can't see the chat for some reason, but I feel like everyone's guessing. So I'm gonna give you 5 more seconds to guess, but their numbers are dwindling. And so as of May, I mean, wasn't that long ago, but as of May, there were 72 left. And so I'm going to pass it back to Miriam to introduce some of these threats.
Thanks, Mel. So obviously, there's what we're facing here, many different threats, mostly, unfortunately, are human caused. But we're mostly talking about, like, there's the climate threat, climate change and impact to habitat. Then there's the sound pollution and physical disturbance and prey availability. And what I'll be talking about is the chemical pollution that is affecting the whales. So this is a great diagram that shows kind of the process of what we're going to talk about, which is called bioaccumulation. which is the gradual accumulation of toxins, PCBs in particular, from prey to predator. So as you can see, like these are all what we call trophic levels. And so you see like there's the plankton, they absorb the PCBs from like chemical runoff from factories, acidic precipitation. So they absorb that, and then zooplankton, who eat phytoplankton, absorb the toxins that they absorbed, and it's just a gradual accumulation of more and more toxins. So plankton, then the zooplankton, then the herring eat the zooplankton, then the salmon, and then you have your apex predator at the top, which is the orca, and they eat all of the salmon that has gradually accumulated all of these toxins. So you imagine there's just all of this build up of the toxins that are absorbed into the fat. So something that's people have asked, like, how long do whales live? And it's a hard question to answer because it differs between males and females. Because of females, when they are pregnant, they offload all of the toxins. They are not all of them, but they offload parts of the toxins that they've accumulated with their pregnancy, and it's transferred to the calves, which is also another reason why we're seeing a declining rate of calves who are, they have a lower chance of survival, is what I'm trying to say. Because of all this accumulated toxins that's absorbed into their fats and the milk, they can't survive as such a small calf with all that toxins in their bodies. So that is also another reason for the declining rate. It's not the only reason of why there's not as many pregnancies. It is mostly because the calves will only live a couple days afterwards. And yeah, so it's really sad. Yeah, there's no words. It's very sad. But compared to the males, they have shorter lives compared to the females because they don't have a way to offload those toxins. So they will have a shorter life period compared to the females who are offloading with each pregnancy. But then they won't actually be able to reproduce more because of the calves. So yeah, there's more about that, but we're gonna take it to Misty now, and she's gonna talk more about the other threats like sound pollution. So Misty?
Sure. Do I take over?
If you can request remote. There we go.
Awesome. Well, thank you both. What a great introduction from the evolution all the way into the start of these threats. So that was really great, you guys. Yeah, and I'm going to pick up right there. Okay, how did I get control? There we go. Okay, and expand just a little bit more on what you were just saying, Miriam. And when we look at killer whales and humans, our biology can be very similar, and the age that females live, the age that males live, it's very similar between human and killer whale populations. The age that females start having children, the age they stop having children, the fact they go through menopause, all of these incredible similarities between human biology and killer whale biology, with one really important exception, and that is that we navigate our world and survive in our world largely with our eyesight, and killer whales largely use sound to navigate through their world. And we're going to get into that a little bit. But I'm going to pick up on where you guys were a little while ago, talking about clans and about different populations that we have in the Northeast Pacific Ocean. And these are sort of a broader scale of populations, which you define, Miriam. This you flag the southerns and the northerns, but if we keep going further up into Alaska, we've got a population that's in the Gulf of Alaska, and then we've got a population over here in the Aleutians as well. And you can kind of get a feel for the range of these different killer whale populations across North America. And one of the first questions I might throw out is, if we were to take that map and not put a killer whale on there, what other species might come up as having the same overlap in range? I'm going to show you the, oops. Can I get out of that, Mo, or do you guys have to?
Here, I can pick up where it was. Oh, hold on. Oh, there we go.
Okay. So here, I'll try clicking again, see what happens. Do I have to try taking over again?
Oh no, you have control.
So if it's, oh, there we go. Okay, sorry, I'll figure this out. Okay, so if you said salmon, and specifically Chinook salmon, you would be right that the overlap of these killer whales in their marine habitat is the range of salmon from Central California all the way up to the Bering Sea. And it's not, it's many aspects of salmon that these killer whales are dependent on. And the one we hear the most about is the numbers of salmon, or the abundance of salmon, Chinook salmon specifically, that have been in decline, and that's possibly or likely the dominant reason that killer whales, southern resident killer whales, are struggling, is the decline in the abundance of that salmon. But it's not just the salmon, it's also the run timing of the migrations back to their fresh water. And one of the reasons that killer whales evolved to depend on Chinook salmon is because these salmon are essentially available year-round. Whether you're down in California or up in Alaska, you've got populations of Chinook salmon that are returning to their rivers literally every month of the year, especially in California. There would be a spring run, a summer run, a fall run, and a winter run. And then the end of the winter run would overlap with the beginning of the spring run. So killer whales would have known that there would have been salmon always returning to the Central Valley, the Sacramento, the San Joaquin river systems, and would know when and where to go to look for salmon. So that run timing is really important. And it wasn't just the any old salmon. The Chinook salmon, as Miriam had said earlier, get to the biggest sizes and the oldest ages. And it's the size of that fish that also had enough caloric value to fuel a killer whale. And as both of you guys mentioned earlier, these fish were also shared, and the females provisioned for their calves, but often the catching of a salmon by one whale would be shared with another member of the family. And then as I was saying earlier, this role of sound is so important in their ability to catch these fish, and we're going to get into that. So just to taking a little bit deeper dive, what this figure is showing is the work of another biologist that once worked with Dr. Michael Biggs at the Pacific Biological Station, or Fisheries and Oceans Canada, and that is Dr. John Ford. And one of the things that he revealed was that the birth rate, the survival, and the death rate or mortality of killer whales is associated with the abundance of Chinook salmon. And that's what this figure is showing. So that this is just looking at mortality, but in years when Chinook abundance is high, mortality or death rate is low. But then when Chinook abundance declines, mortality increases. So it's this connection between the abundance of salmon and the vital rates of killer whales. And this figure is showing two things. It's showing the Chinook that are returning to the Fraser River And it's showing us that that historically, and even the full range isn't quite on here, but historically Chinook would have come back into the Fraser River starting in March. And they would have different waves of runs coming in. So they'd have a spring run, they'd have an early summer, they'd have a summer, and then they'd have a fall. So from March through to the end of October, there would have been Chinook coming back into the Fraser River. And the presence of killer whales in the Salish Sea is really tied to that abundance of Chinook returning to the Fraser. And then the other thing that this is showing is that historically, and this is only going back to the 1980s, but if we were to go back to the turn of the century, in the late 1900s and early 20th century, the spring run would have been the largest run into the Fraser River. And this is capturing a little bit of that, but you can see that this historic black line of the amount of salmon that were coming in just since the 1980s is significantly larger than this red line, which was showing the amount of salmon that came in 2018. And importantly, there was hardly any salmon that showed up in the Fraser River before June. And it's the loss of these fish coming in the earlier months that may be the reason why southern residents are not arriving in the Salish Sea as predictably as they used to in the past. So, and then we get into the size and the age of these fish. And Chinook could historically reach ages up to 7 years old, but today it's the number of 5-year-olds and 6-year-olds and 7-year-olds becomes increasingly rare with that age. And this figure over here is showing that that killer whales really wait until the size of the fish is bigger than 70 centimeters, so a little less than a meter, before they really start to feed on them. And the problem is that we don't see these ages and sizes of these big 100-pound-old fish the way we used to. And nowadays, a 50-pound Chinook salmon is considered quite a large fish. These 100-pound giants that used to be around and used to sustain these whales are much fewer in abundance than they were decades ago, and even a century ago. So then that other piece is, okay, so we have these big fish, they're available year round and there's enough of them to sustain these whales, but they have to be able to catch them. And what this figure is showing is the echolocation system that killer whales use, which is the same system that we're probably more familiar with hearing about, and that is how bats echolocate, how they navigate and move, sending sound and having it bounce off an object and echo back in so that they can detect that sound. So or that object, sorry. So in killer whales, they would take a breath, the air would come in, it would go through air sacs and this organ called phonic lips, and that air would be changed it would move into this area in the top of the head called the melon. And the melon is an oil-filled reservoir, and the killer whale can move that reservoir by turning and moving its head, and it can direct the sound that's going to come out of the melon and direct that almost like a flashlight beam toward the objects, and in the case of salmon, the prey that they are looking for. And then that sound would go out, and then if it finds a fish, the fish would send the sound back, and the whale would receive that sound through its lower jaw, more oil in a reservoir in the lower jaw, and then that would send a signal to the brain. And that would give the whale an amazing amount of information. It would say, this is the size of the object, this is how fast the object is going, this is the distance to the object, And it's so refined, this echolocation mechanism, that a killer whale could distinguish based on the size and the shape of the swim bladder in the salmon, whether or not that is a Chinook salmon and whether or not they want to go after it. So it's an incredible mechanism that requires them to be able to hear and receive, or send out and receive that signal. And this is some of the problem that is happening as we industrialize the Salish Sea, as more and more vessels, and that's everything from these great big ships that are coming into places like Roberts Bank, Fraser Surrey Docks, or Burrard Inlet, to small vessels that, you know, could be out fishing or whale watching or any other activities that are happening on the water. And these vessels are affecting them in a couple of ways. One is that the physical presence of the vessel can change the behavior of the whale, but more importantly, the sound that's coming out of those vessels can interfere with the calls, the echolocation, and the communication of the whales. And Mo, I think, is there a, oh, there, okay. So I'm just gonna play a clip that gives you an idea of what it's like for a killer whale to be trying to listen and send signals, hear and communicate in the presence of, in this case, these large ships. So it's like us being in a crowded room or in a bar and trying to have a conversation with the person sitting beside us, and the music being really loud and you can't fully hear. And what happens is that you have to raise your voice, and that's what killer whales are doing. They're having to raise their voice in order to communicate. But they also have to be closer to, say, a fish in order to hear the echo, receive the echo back, and detect that sound. And the frequency of the noise can overlap those frequencies that the killer whales are communicating in. And all of these pathways of interference translate to not catching and consuming as many Chinook salmon. And so it's another way that they're not getting enough to eat. Okay, so just in summary, we've talked about that it's important that we have adequate abundance and numbers of Chinook salmon. It's important that they're available year-round, that they're the oldest, that their population structure maintains the big and the old fish, and then the importance of having a quiet environment in order for them to hear and be heard. So these factors are part of the bigger picture of why southern residents are struggling as much as they are. And as Miriam said, they're critically endangered, and that we're down to 72 of them. And this in conjunction with the fact that for the last few hundred years, they've been a small population. There was killer whales that were removed for the aquarium trade. Salmon habitat is being impacted by habitat loss, by climate change, by many other factors. And we're really on a precipice for whether or not these whales can persist into the future. And Raincoast, to sort of ask this question of whether they can recover, teamed up with many scientists a few years ago, and we looked at the viability of these whales into the future. And in 2015, we found that if we were to implement threat reduction measures, which meant increasing the abundance of Chinook and reducing the noise, that a population of 80 whales had a likelihood of still being present in 100 years. There was only a 9% probability that a population of 80 whales would be what's called functionally extinct, which is when you only have one sex remaining or very few whales, that they would be functionally extinct within 100 years. So only a 9% probability. But in the last 5 years, the critical habitat has further either declined or been degraded within the Salish Sea. Factors like contaminants have contributed to very low calf survival. We've had more mortality of adult whales, and now we only have a population of 72 whales. So if we do the same analysis that we did in 2015 on a population of 80 whales, today on a population of 72 whales, we've found that what was once only a 9% probability of being functionally extinct in 100 years is now a 59% probability of being extinct within 100 years. So the situation is getting really dire for these whales. And if we continue to do nothing, which is not address these threats in a fully adequate manner, the status quo is that they will go extinct over the next 100 years. But the preferred option and the option that is still available to us is recovery. And it requires addressing salmon habitat, fighting climate change, addressing the contaminants that are draining into their waters, improving Chinook habitat and Chinook salmon, and reducing the noise within the Salish Sea. But we can do all of these. We've started doing all of these, and it's possible to still recover. So just really quickly, because I know I'm running out of time, in the last couple of years, some important measures have been made, led by the federal government in Canada, and we've seen protected areas for feeding and sanctuaries been proposed and identified and implemented now. We're in the second year of that. There's now a 400-meter distance that anyone can approach a killer whale, especially the southern resident killer whales. The whale watching companies have agreed not to follow southern resident killer whales, so there's effectively no whale watching in Canada now on southern resident killer whales, and that's a really important initiative that the whale watching companies have been involved with. Mechanical upgrades and technical upgrades are being identified for ships. Ships are slowing down through important areas where killer whales feed, and when ships slow down, it reduces the noise. But there's a couple of things that we're not seeing the progress on, and one is the amount of salmon habitat that's being protected. We continue to make really bad decisions about the importance of salmon habitat. And there still is more Chinook fishing than should be happening, given that, that these fish are so important for whales. And we continue as society and the federal government to not address the growing industrialization within the Salish Sea from these big shipping expansions. And Kinder Morgan is one of those projects with its oil tankers, and the Terminal 2 expansion at Roberts Bank near the ferry terminal is another one of those expansions. So the white are the areas where we're making some real progress. The yellow are the areas that we still significantly need to make progress on. So I'm going to pass it back over to you guys, leave it there. Thank you, and we can answer some questions.
Yeah.
But you're going to tell us more, Miriam, aren't you?
Yeah, so if Mo, you just want to go through the slides here, we're talking about what can you as an individual help, and it really comes to speaking out, using your voice and challenging what is going on. I can't.
Oh, okay.
1 second. There you go. A great quote from Gandhi, be the change you wish to see in the world. Which brings us to this week's challenge. So we are asking you to speak out and educate others and yourself. And by doing this, we're asking that you engage in an online climate strike. So these have been going on for a while with the Fridays for Future. I don't know if you guys have heard of it. It's been fairly popular. So what we're asking you to do is create a poster, a picture representing the threats to killer whales and salmon, just for this week. Or not just this week, but in general, specifically for killer whales. So how you do this, post a picture with you and your sign on social media using the hashtag for digital strike. And then if you tag Raincoast into your posts or send it to Maureen, you can be entered into our draw for a prize. And additionally, you can send your photo to the Instagram page, and it can be put into their weekly submissions. So here we have some of the Earth Guardians from Cowichan, and these are some of the signs and posters that they've made over the quarantine. This is Katya and her poster of her whale. It's one of my favorites. Gives a great image. So yeah, something to be creative about. Explore. These are the Instagram pages that you can follow and check out for more information. Here we have the Cowichan Earth Guardians, which is local to my area, but if it's not, look out. There's many different organizations if you do a little research. And then the International Fridays for Future. So yeah, get out there and start educating others, educating yourself, and speaking out to these threats and issues that the whales are facing. And yeah, now I'm bringing back to Mo.
Thank you. So yeah, thank you everyone for all of your knowledge and information. I know we've gone a little bit over today, but today is a topic that a lot of people are very, very concerned about and interested. And so we had a lot of great things to talk about, but we definitely want to hear from you and open up for Q&A, because I'm sure there's lots of questions about this topic. And if you have to go, that's okay. We won't feel offended. We also will have these episodes recorded and uploaded to our website and YouTube page. So if you do miss something, you can always come back. But yeah, we will definitely just open up the floor now for anyone who has questions. I just want to shout out to our sponsors for helping us make this possible. They've been very supportive with educating all the people in our communities and throughout Canada and beyond. And so thanks to all of our sponsors. I'm gonna stop my screen share for now. And yeah, so let's take questions. Let's see. Okay.
I just answered the one in the Q&A about if offshores eat the whole shark. I can't really confirm that, but they're not killing the shark for the rough skin because it doesn't have much nutritional value, but research says that it is. It's the liver that they're going for.
There was some fascinating, there was some scientists that were finding these sharks, this would have been in the Atlantic, and they had this incision in them behind their gills. And that was the only real sign of entry. And these sharks were dead with this incision behind their gills, and their livers were removed. Mm-hmm. And yeah, so I think you're absolutely right. They're going for their livers, Miriam.
Yeah.
Okay. So I haven't been following the chat as much, but if anybody has, a question, let me know. I do see one here. Has there been any opportunity during COVID to do any hydroacoustic studies to measure the noise difference?
It's a great question, and I don't think that the results are in. There has been, initially, people were thinking that noise was going down and that the ocean, at least in the Salish Sea, was getting quieter, but there may not be that evidence. And the Salish Sea was, again, some of the early anecdotal comments and perspectives from people who study this is that the Salish Sea may not have gotten as quiet as people were like wanting to believe. So the verdict's out. The jury is still out on that.
We have a question from Nate here. Hi, I have a question for Mo. This is for me specifically. Okay, why are the different orcas ecotypes and not species? Oh, for anyone. Oh, okay, it's for anyone. Anyone. I don't know. Misty, do you want to take care?
Yeah, it's a fantastic question. And I think that they may be moving in the direction of at least subspecies, if not fully separate species. But they're not, because the ecotypes, as Mo, you described, are so distinct from all these different perspectives, their ecology, their diet, their language, their all of these habits. And there's no interbreeding, that they may be going in the direction of separate subspecies.
Awesome. Yeah, I think they estimated between the resident transient, the last common ancestor was something like 700,000 years ago. So it's
Wow.
diverged quite a bit. Okay, there's some questions in the Q&A box. Are there any special traits that the female has that the males don't have that can help lead her pod?
So that sounds like a question about, so as part of the cultural knowledge, that as the females, I think that's about your matriarchs, but that grandmothers carry the knowledge, and that they have this knowledge of when and where to find salmon and those migration routes, and they pass that knowledge, just like their dialect, down to their children. And in the case of the dialects, they're holding it on for their entire lives, that dialect, and passing it on. But that information is being held by the oldest females and the grandmothers, and then passed down through those matrilines that you were describing.
Mm-hmm. There's a question here from Allison. Is the population getting a bit better during the pandemic?
So it's a very short period over which to examine any trends. So the population was 72 at the beginning of the pandemic, and I believe that the population is still 72 now, unless there's been, calves born or whales die in that period of time, and researchers don't know yet.
Mm-hmm. Yeah.
There could also be looking at that the health of individual whales that the drone work is doing, and I don't know about the answer on whether researchers are seeing a better robustness and fitness of individual whales. Good question.
Mm-hmm. Of the 72 whales, I guess the residents, do we know who's the oldest and how old they are?
I think that since Granny died, and Granny was J2, and she was believed to be more than 90 years old when she died, I think that the next oldest female would be from L pod, maybe L25, Ocean Sun. And she's probably getting quite old now as well. So she would probably be the oldest female. But somebody could Google that really quickly and tell me. So somebody Google Ocean Sun L25 and find out how old she is, and whether she's the oldest female in the southern residents.
So is Granny estimated to be like one of the oldest killer whales that have existed? Like, do you know what is the oldest age that killer whales have been recorded as?
It's a good question. The southern residents are the best studied population of killer whales in the world. So we know the fact that we would actually know how old an individual whale is, who all of its children are, what relation all of its children, its grandchildren, its great-grandchildren have to every other member in their pod and within their clan, it's an incredible amount of information. And I would I would suspect that we just don't have that kind of information for other pods like we do for the southern residents, thanks to all these amazing scientists that study them on both sides of the border.
Mm-hmm. I'm going to give this one to Miriam. Do females live longer than the males?
Indeed, they do. I mean, it's more complicated than that. But if you weren't here at the beginning, we talked about bioaccumulation, which is one of the reasons why males don't have as long as a lifespan compared to females, because they have no way to offload the toxins as females do when they are pregnant and give birth to calves. Does that answer it? So yes,
I think so.
the females, they run the world.
Yeah. Yes, if only. Okay, I'm gonna take one last question just because I'm conscious of the time. This one is asking: are the females the main ones who hunt?
Yeah, it's a good question. You guys weigh in too. I think the males also hunt a fair bit. So yeah, I'm going to hesitate to say definitively on.
Yeah.
What do you think, Miriam?
I'd say it'd have to depend on the pod and the matriline, like, you know. But what I have read was it is mostly females that do the hunting, but yeah, I don't think you can have a definitive answer on that.
What I've heard too, and I don't know if this is true or not, but I've heard that the females will share, like will bring up and share the fish, whereas males' the tendency is it's not as much.
Yeah.
So I don't know if that is true or not, but females definitely do share.
Yeah, females hunt for their pod or their matriline, and males would, yeah, slightly more selfish. Who knows? They're whales.
All right. Well, I'm gonna stop it right there, just because we had a lot of information, and hopefully everyone can digest that and take that and spread it with the people around you and share your knowledge. But hopefully everyone enjoyed the presentation about killer whales. We will definitely have that up for everyone and anyone to share on our website and our YouTube page. So stay tuned for that. Next week, we have Nate, who will be hosting and presenting as well, with another junior leader. So Miriam, you met Ryder, our other junior leader, and we have our last junior leader, Chloe, who will be sharing more about this intertidal world. So looking at all the different things that live in there and the importance, but stay tuned for that. So hopefully everyone enjoys the rest of their day. Thank you to my presenters, my co-presenters. You guys have any last words?
You guys are awesome. Thank you. And Miriam, your knowledge is amazing. And thank you both of you.
Awesome.
It's been an honor to learn with you guys. It's been really fun.
It's such a pleasure to be able to present with you guys. And thank you all the attendees. Hope to see you again. Bye, everybody.